Hi, this is Alex from devstories.eu. Pydantic Data Validation, Episode 5 of 20. Pydantic's eagerness to turn the string 123 into an integer is a killer feature, right until it silently hides a data type bug in your JSON payload. You expect numbers, you receive strings, and your application happily proceeds until a strict downstream system crashes. The mechanism controlling this behavior is data coercion, and taming it requires understanding strict mode. By default, Pydantic operates in what the documentation calls lax mode. In this mode, Pydantic acts as a data parser rather than just a type checker. It actively tries to coerce, or convert, incoming data into the type you declared. If you define a field as an integer and the input payload provides the string 123, Pydantic evaluates the string, extracts the valid number, and transforms it into an actual integer. This behavior is incredibly useful when processing user input from web forms or query parameters, where every incoming value is fundamentally a string. However, when you are building machine-to-machine APIs, silent conversion is often dangerous. If a client promises to send an integer but sends a string instead, they are breaking the API contract. Lax mode covers up this violation. This is where strict mode comes in. Strict mode disables automatic type coercion. When you turn it on, Pydantic demands that the incoming data type exactly matches your type annotation. Pass the string 123 to a strict integer field, and Pydantic immediately rejects it with a validation error. It forces the data source to respect the schema. You have two ways to apply strictness: globally across a model or locally on specific fields. To enforce it globally, you modify the model configuration. By setting the strict configuration flag to true, every single field within that model stops coercing types. A Boolean field will only accept a true or false Boolean value, not the string true or the integer 1. An integer field will only accept integers. Here is the key insight. Global strictness is often too rigid for real-world applications where data arrives from mixed sources. You usually want to lock down a few critical identifiers while leaving the rest of the model flexible. To achieve this, Pydantic allows local strictness. You can enforce strictness on an individual field by using specialized types provided by the library, such as strict int, strict str, or strict bool. If you define a user ID field using strict int, that specific field will reject string representations of numbers, while the rest of your model continues operating in lax mode. You can also achieve this by passing a strict flag directly into the field definition function for any standard type. Consider a service processing a JSON payload for a financial transaction. The payload contains an account ID. If defined as a normal integer, a payload delivering the account ID as the string 123 passes right through. Pydantic fixes the data type in memory. If you update that field to use strict int, the exact same JSON payload fails validation. The client receives an explicit error stating that the input must be a valid integer, catching the contract violation at the system boundary before it pollutes your database. Strict mode shifts Pydantic from being a helpful parser that cleans up messy inputs into a rigid enforcer that guarantees data contracts. Thanks for listening. Take care, everyone.